Today's question is threesome. Question says, given an integer array nums, return all the triplets nums I, nums j and nums k such that I is not equals to j, I is not equals to k and j is not equals to k, and nums I plus nums j plus nums k will be equals to 0. Notice that the solution set must not contain duplicate triplets. So what it is trying to tell us is, we have an integer array and we are trying to find the triplets. Basically we'll have the set of three elements from the given array, and the sum of these this element, the single triplet, should be equals to 0. The extra thing which it has been explicitly mentioned, that if we cannot have duplicate triplets, which basically means if I have paired this -1, 0 and 1, then I cannot pair 0 and 1 with this -1 because it will create a duplicate triplet. So let's see how to solve this problem. The efficient way in which to, because we have to iterate through the array and we need to find the target sum. So it would be very easier for us if we would have an idea that are we going closer to the sum, the target sum. So continuously I am going to, this 0 is nothing but a targeted sum. So I might use 0 or I might use targeted sum. It's 0 only. So if we have an idea that whether we are going closer to the sum or whether we have surpassed the sum and we are going somewhere greater than what we need to get, then the step immediate to it, whatever we need to take in order to go out, in order to get the sum, would be that can be predicted. What I'm trying to tell you is that if I have -1 and if I have -1 and 0 and 1 to the array in this fashion, I cannot predict the direction in which I need to move in order to get the sum. That can be done if and only if we have the array sorted, because I know at the right, if I have sorted in a lower to higher order, then I know the higher elements, the larger elements are there in the right side and the lower elements are there in the left side. So if I'm getting the element which is greater than the sum, then I need to know, I know that I need to step inwards towards the left side. So this kind of predictions will be possible if and only if my array is sorted. So first thing is we need to sort the array. Sorting the array will solve two problems. One problem is we have an idea about the movement. As I was saying, that 2 is the largest element, 1 is the second largest element. Okay, so and -4 is the smallest element in the given array. So if we are moving, if I have added -4 with 2 and I'm getting, in this case I'm getting -2, which is that I am adding very minimum value to the maximum value. Maximum is not an important case in this, since we are getting value very less than the target or less than the target, then we know that we need to increment from this side. We need to go to towards right, because right has larger values, because the answer what we got by adding -4 with 2 was a value lesser than 0, and we want 0. So it helps us to predict the movement. So that is the first reason why we sorted it. We sorted the array in order to know the in order to predict, or in order to decide in which direction we need to move. And the second reason to sort this array was it will be easier for us to find the duplicate elements. If I have -1 and -1 in this array, then I exactly know what would be the location. It will be +1 location or -1 location of that particular value. So if I am at -1, then I know my +1 will be -1, or if I'm here, then I know -1 will be -1, and so on and so forth. So by to help to find the duplicate elements, and in order to efficiently find the sum or the pair of numbers while iterating through the array is the main reason to sort this. So once we have sorted the array, what we are trying to do here is we'll iterate through the entire array. I am iterating till n-2, and here is the reason why. I will be having three variables which will be located at I, j, which is I plus 1, and k, which will be n-1. So what I'm trying to do here is I will be taking, because I need to find the triplets. So what I will do, I will fix an element for ARR I. I will fix an element ARRI, which is this -4 in one first go. Then what I'm gonna do is I will run a loop from here to there, till -1 to 2, and which will be basically, this will be my J, this will be my K. So I will be my first element, the immediate next element will be, and that will be fixed. First I'll get my first element and I'll fix it. Then what I'm going to do is immediate next position, whatever element I have, that will be J, and the last element will be K. Now what I am trying to do here is I'll run a loop from J to K in order to find a pair of elements, which then getting sum with the ith location value will help me to get the sum equals to 0. What that does that mean is I will be running till J is less than K, because J is at location 1 and K is at location 5, and we need to run till, and both has to move. J will be moving forward and K will be moving backward. And the concept which I was telling, that to predict the movement, so if my value, my sum is greater than 0, because this is a target, greater than target, then I am going to do K minus minus, because this guy is pointing here, K is here, and I know I am already dealing with the largest element, and it is not helping me to get not helping me to go and get the target. It is rather than making me greater than the target, so I need to ignore the largest element which right now I am dealing with. So K will be minus minus, so K is going to move towards, the movement of the K will be towards origin, that is still towards 0 index, which is towards the left hand side. And if sum is less than target, then we need to do J plus plus. It has to go to right hand side, because the whatever I have got, whatever sum I have found, which is not equals to 0, rather than it is less than 0, so I need to ignore the smallest elements which right now I'm including. So I will move one step forward. And this is the strategy which we do not only apply in this question, but whenever we are dealing with, whenever we are traversing from one point, like one index is at the 0th location and the other index is at the last location, and we are traversing, so basically 2-pointed problem it will be, and we are trying to deal with both of the elements and trying to take a decision. And if the decision is something which where we are trying to get some target value, and then we can predict the movement, that which index has to move in which direction. So for this purpose we have actually sorted it. Right now only we discussed, and I am repeating it again. So in this when we are when we have already fixed our I, and we are trying to find our J and K pair from these elements, the same methodology we are going to apply. Since we already have our index pointed to the specific locations, the very first thing I'm going to calculate is sum, which is nothing but ARRI, because I know where my I is, I know where my J is, and where my K is. So I will try to find, I will get the sum. Now once I get the sum, which will be in our case -1, no sorry, since I have sorted it, I'm going to work on this array, so it will be -4 plus -1 plus 2. So these three elements will be our first pair. Now it is our call to consider it as a pair or not. And in question it has been explicitly said that if this sum is equals to 0, then only we'll say that, hey, we got the triplet. If we have not got the if the sum is not equals to 0, then we are going to iterate through this J to K. Not even J to K, we also have to iterate our I from 0 to n-2. Why n-2? Because we have an extra two extra variables J and K which is already there, so we can't go till n, because last two elements will be occupied from J and K. We are trying to find triplets. So if we found, for an instance our first pair, just forget about this, but for an instance just imagine we have an triplet which is satisfying this condition, then we are going to push that. We are going to push that in our result answer vector. Okay, and once we have found our first triplet, it's not the end of the answer, it's not the end of the code. We want to find all the pairs which getting combined with -4 will result to 0. So in case if we found -4 with some j and k valid pairs which is helping us to get the 0, we also are interested to know more pairs. So for that we will be iterating more. So it should be j minus minus and k plus plus. The movement will be same. J will be incremented. J will be going to the right direction and k will be moving to the left direction, because we are already pointing to the end point. So it should move towards this left direction. And if we are greater than 0 or less than 0, then this is the movement which we are interested to know, which we already defined on top. That else if sum is greater than 0, then who is responsible for that? K is responsible for it. So k has to go minus minus. And else we will say j plus plus. So it's a simple movement. If we know the direction in which we need to move, and if we know that how to efficiently, because we could have done in this 3 loop, one is iterative, one is fixing I, another is fixing j, another is fixing k, but then that will be not sufficient way to solve this problem. So the efficient way to solve this problem is first fix this I and just run a loop for finding the pair. So that will be that will help us to reduce the complexity. It won't be n cube in our case. So let's try to solve this. Whatever I have discussed, I'm going to code the same in the LeetCode platform. So let's just try to understand here. Alright, so base check, because we can have empty elements. So let's first get the size. I'm saying n will be my size, which is nums dot size. Okay. Then the second important thing is the base check, which says that hey, if my n has less than 3 elements, which means that I can't find triplet at least in this kind of situation. So I'm going to return empty vector, and everything goes well. Then the very first thing I'm going to do is I'll sort the nums vector. Okay. And then I'm going to create my answer array. Okay, so it's vector of integer. It's ans. I try to use the same variable what I have discussed while explaining, so that you are able to connect it more better. So far what we have done, we have got the size. This is the base check, because if we need to find, we are here to find the triplets. If we do not have 3 elements minimum, then we can't find triplets in that case. So if it is less than 3, then we are going to return. Then the first thing, sort. Why we are sorting, I have clearly mentioned earlier. And then here we come, here is the return type vector of integer. So vector of integer we have created. This will be storing the elements, the triplets. So now we go and run the loop for I, j and k. So we'll fix I, so it should go from 0, I is less than n minus 2, then I plus plus, then we get our j, which is nothing but I plus 1, and then we say hey, I have k, which is nothing but n minus 1, because it is going to point to the last element. Now what are we trying to do here is we'll run from j till k, so it should be less. What we'll do is we'll get the sum, which is nums of I plus nums of j plus nums of k, and we have the checks. If sum will be equals to 0, then we are good. So we'll be push back these triplets. So it should be nums I, there you go, nums j followed by nums k. We got our triplets and we want to find more. So as I said, j will be always incremented, k will be always decremented. But what if what if our sum is greater than 0? Then we have just discussed it's the responsibility of the element which is at the highest end, which is at the leftmost side, so k has to be decremented. And if this is not the case, then obviously j has to be incremented, because we are in the another case where the sum is less than 0. So this is it. So here we close while, here we close for, and by the end we are going to return ans. But something is missing at this point in time. So we have not handled the situation where we are saying that we are not going to entertain any duplicate triplets, because we did not check anywhere. So duplicate triplets means what? The duplicate triplets is like whenever I have I, it's nums I, the very next element or the previous element which I have will be equals to this element which right now I'm dealing with. So nums I minus 1. Okay, so this has to be it should be distinct. If it is not distinct, then it means that we are dealing with the duplicate elements. So whenever we are dealing with this entire calculation, the very basic which we need to do here is that whatever element I am dealing here, so let me go back to the whiteboard. Here, whatever element I am dealing with, like minus 1, if it is equals to I minus 1, then I am dealing with the repeated element. So let's just ignore this and move forward. Okay, so that's what I'm trying to do here. If it is not equals to, then only I'm going to do this. And obviously I need to exclude this check for I equals to 0, because I does not have I minus 1. Sorry, 0 does not have I minus 1 location. So this will be the extra check which will be handling the duplicacy. And here you go. Alright, I hope the integration is okay. And this is the end of if, this is the end of for. Wait, we still have something to handle. Whenever we are jumping, then that was the I who was handling the duplicacy, but we should not forget that j and k will also have the same situation where they need to jump. Okay, so always whenever we are dealing under the loop, we need to, and when we are incrementing decrementing, we need to check the boundary condition. So boundary condition is always j is less than k. So if this is the condition, okay, and whenever my nums jth element will be jumping to j plus 1, so if that is the case, then simply do j plus plus. You step ahead. And similarly, if j it should be less than, until this is the case, then nums k should equals to nums k minus 1, because I'm decrementing it, so I'm expecting the element k minus 1 to be compared with, so it should be minus minus. So I'm just jumping. If I'm jumping from let me go back here, and if I'm jumping from 2 to so just imagine this is 2, then in when there is a situation where k has to be jumped, it will not go to location 4, but it will go to directly location 3, because it is repeating. So I have handled duplicacy at ith location by adding this check, and j and k has also handled its duplicacy in case if it is occurring in I equals to, I mean, this condition. So I hope this should be fine. Let's try to run it and see if this is working. Alright, it got accepted. So let me just recap it. So what we did, we got the vector, we are trying to get the sum, we got the sum, and sorry, not sum, we got the size, and once we got the size, we'll check, because we need to find the triplet. It should have at least 3 elements. If not, then return from there. The second thing is like we sorted the array. The importance of sorting in this particular problem has been explained in the while discussing in the whiteboard. So that's why we sorted the array. And then what we did is like, because the return type is vector of vector integer, and obviously it has to be because it is holding the triplets. So one vector is the triplet, and it's like collection of the triplets. So it will be vector of vector and integer type, because obviously these are integer values. So we'll create a result which will hold the values in it. And then finally what we're trying to do is we are iterating using I, j, and k. So j and k is pretty straightforward. Whenever we are dealing with to get closer to a target, we need to predict the direction where j has to move, where k has to move. So j and k is doing its job as it is. What extra thing we are doing is we are fixing I for j and k. So we have I and j and k. Once we have all these variables, we'll sum it and we'll see that whether we are getting 0 or not. That is our target. If we are getting 0, then we'll push that into the answer we have created. Otherwise we'll move, and since we have sorted, we know the prediction, we know the direction in which the movement should happen. It should be k minus minus or j plus plus. So this way we'll move through the entire array and through the entire I location, and we'll get all the possible triplets which we can create. And we have successfully avoided the duplicacy by adding a one check here where it says that whatever element I'm dealing with, if the previous element is also having the same one, then we'll not entertain that, or same goes to j and k location as well. So let's just try to submit it. Alright, it got submitted right now.